So what in the world does building a city have in common with building a data warehouse? Well, it turns out a lot more than you might think. See, it's not about just buying the biggest, most powerful hardware you can find. It's really all about smart architectural planning. If you get it wrong, you've basically built a ghost town of data. But if you get it right, you've got a thriving metropolis. All right, let's kick things off with a question I hear all the time. Isn't a data warehouse just a bigger, more powerful version of a regular database? I mean, it's a tempting thought, right? But honestly, the reality is so much more nuanced. And getting this wrong, well, that's pretty much the first step toward a project that's doomed to fail. And this slide just perfectly nails the difference. So on the left, you've got systems for running the business. Think of this like the daily traffic in a huge city. I'm talking millions of small, super fast transactions. Buying a coffee, catching a bus, it's all about now, now, now. Speed is everything. But on the right, that's for analyzing the business. This is like planning a brand new skyscraper. It's a huge, complex project that looks back at years of data to make these massive strategic decisions. You wouldn't use a sports car to haul steel beams, right? And you wouldn't use a giant crane to deliver a pizza. They are just different tools for completely different jobs. So here's a much better way to think about it. You're not just building a single house. You are planning an entire city's infrastructure. You have to think about the roads, the power grid, the water supply, all these massive systems that are going to support thousands, maybe millions of people, not just one family. That's the mindset we need to be in for planning a data warehouse. Okay, so if we're going to plan a whole city, where do we even begin? Well, it's not with bricks and mortar, or, in our world, servers and storage. Nope, we start with the master plan. And that master plan is built on 5 core questions that are going to define absolutely everything else. And here it is, the master plan. First up, data volume. That's basically the size of our city's population. How much data are we dealing with? Then, reporting complexity. This is about the kinds of buildings we need. Are we building simple houses or these crazy, complex skyscrapers? Next, users. That's the traffic on our roads. How many people are trying to get information at the same time? Then there's availability. That's our power grid. Does it need to be on 24/7, no exceptions? And finally, ETL. This is our entire supply chain. How do we get resources into the city in the first place? Let's take a closer look at that one because it's a big deal. All right, let's zoom in on ETL because this thing is an absolute beast. It stands for extract, transform, and load. So you're extracting all this raw data from dozens of different places, then you're transforming it into building blocks you can actually use, and finally, you're loading all of it into the warehouse, our city. This isn't just a simple pipeline. We're talking about a massive industrial operation. And as we're going to see in a bit, it is one of the most demanding jobs our system will ever have to do. Now, here's where it gets really interesting when we talk about that reporting complexity. See, it's never just one type of question people are asking. A typical medium-sized system might have a mix that looks something like this. About half the queries are simple lookups, another 40% are more involved reports. But then there's that critical 10%. These are the really complex, deep dive analysis tasks that push the system to its absolute limits. And honestly, understanding and planning for that 10% is key. Okay, so once we've answered those 5 big questions, we can finally start to get a real sense of scale. Are we building a small town here, a bustling city, or are we talking about a massive, sprawling metropolis? Let's figure that out. This table really pulls it all together. Let's just trace that medium column for a second. So for a medium system, you're dealing with somewhere between 1 and 10 terabytes of data. Your reporting mix is what we just saw. You need to be able to support, say, 100 to 200 people using it at the exact same time. You can probably handle an hour or 2 of downtime here and there, and your data needs to be refreshed multiple times a day. All of a sudden, those abstract questions start to create a really concrete blueprint for our city. So we have our city's blueprint. Awesome. But now we need to understand the daily grind. The actual work that's happening on the streets. These are the key workloads that our infrastructure has to be able to handle, day in and day out, without breaking a sweat. The first, and often the absolute heaviest workload, is that ETL process we talked about. This is like the city's entire supply chain running at full tilt. Just imagine trucks totally clogging the network, factories, which are CPU and memory, working crazy overtime to transform all the raw materials, and these giant cranes, or I/O, working nonstop to place everything where it needs to go. I'm telling you, this one process alone can bring a poorly planned city to a grinding halt. Okay, next up is data model processing. The best way to think of this is like the city's logistics department, organizing everything so it's super easy to access. What the system is doing here is pre-calculating and summarizing a ton of data, so reports can run in seconds instead of hours. It's kind of like pre-packaging all the goods for the supermarket. But that whole packaging process, it's another incredibly intensive operation that just hammers the system's resources. And finally, we get to the workload everyone actually sees, the reports and the analytics. I mean, this is the whole point of the thing. But it is also a major resource strain. Pulling a massive report that has to scan billions of rows of data is an I/O nightmare. And running some predictive data mining algorithm, that can max out every single CPU core you have. So we've planned for the supply chain, we've planned for the logistics, and we've planned for the citizens' needs. We're done, right? We can just pack up and go home? Not quite. There's one more category of work that is absolutely critical, but man, it often gets completely forgotten in that initial planning phase. And that's system maintenance. Yeah, think of this stuff as city maintenance. So indexes are kind of like the city's map directory. They help you find things fast. But as a city changes, you have to reprint the map, and that's a huge job. And backups, that's your city's emergency evacuation plan. You really hope you never ever need it, but you absolutely have to have it. And running those drills takes up a lot of resources. You have to budget for this hidden work, or your city will eventually just fall into disrepair. You know, this quote from the source article really just ties it all together perfectly. A data warehouse is not a standard database. It has its own unique characteristics, its own unique workloads, and its own unique requirements. It demands its own specialized approach to infrastructure planning. If you treat it like it's just another database server, you're really just setting yourself up for failure. And that leaves us with one last really critical thought to chew on. You can plan for the data, you can plan for the reports, and you can plan for the users you have today. That's great. But the entire point of a data warehouse is to answer questions you haven't even thought of yet. So the real challenge isn't just building an infrastructure for today, it's building one that's flexible and scalable enough to handle the business of tomorrow.